Welcome back to the Cisco Introduction of Networks lecture series. If you would like to look at the previous modules, I will leave a link in the description for the playlist. Today, we will be covering module number 13, which is ICMP. In this module, we will learn about ICMP messages and explain how ICMP is used to test the network connectivity. We will learn about ping and traceroute testing, which use ping and traceroute utilities to test the network connectivity. Remember, ICMP is the protocol that we use when we try to ping a device from another device. So that's what we will be covering in this particular lecture. ICMP messages. The ICMP version 4 and ICMP version 6 messages. The Internet Control Message Protocol, also known as the ICMP, provide feedback about issues related to the processing of IP packets under certain conditions. ICMP version 4 is the messaging protocol for IPv4, while the ICMP version 6 is the messaging protocol for IPv6 and includes additional functionality. The ICMP messages common to both ICMP version 4 and ICMP version 6 includes host reachability, destination or service reachability, and time exceeded. Please note the ICMP version 4 messages are not required and are often not allowed within a network for security reasons. So, if you try to send an ICMP version 4 ping message to certain servers, for example, you may not reach that server and that ping ICMP packet may not go through because they may be using firewalls to block those ICMP packets. So that's what it means by, it is not required and sometimes not allowed within certain networks using those security policies. Host reachability. ICMP echo messages can be used to test the reachability of a host on an IP network. I would say in most situations, that's what the ping messages are used by most of the network administrators and developers, just to test that you can reach a device on the network. In the example here, the local host sent an ICMP echo request to a host. If the host is available, the destination host responds with an echo reply. So what happened is that this particular host, say this H1, send a ping message, which is an ICMP packet, to this host 2 with the IP address 192.168.30.1, and that ICMP message goes through this network and these routers and switches and reach this device, H2 device, and when that device reply back, that would be a response, an echo reply of that ICMP initial message. Destination or service unreachable. An ICMP destination unreachable message can be used to notify the source that a destination or service is unreachable. ICMP message will include a code indicating why the packet could not be delivered. Few destination unreachable codes for ICMP version 4 are like this. So they are like 0, 1, 2, 3. So the 0 would be the net unreachable, 1 is the host unreachable, 2 is the protocol unreachable, and 3 is port unreachable. And few destination unreachable codes for the ICMP version 6 are like 0 is no route to destination, 1 is the communication with the destination is administratively prohibited, such as I mentioned before, there may be a firewall or security policy that is blocking that ICMP packets. 2 is the beyond the scope of source address, 3 is the address unreachable, and 4 is port unreachable. And please note the ICMP version 6 has similar but slightly different code destination unreachable messages. But the primary purpose of both ICMP version 4 and ICMP version 6 is very similar to each other. Time exceeded. When the time to live or TTL field in a packet is decremented to 0, an ICMP version 4 time exceeded message will be sent to the source host. So the source where the initial message will be sent out will receive a time exceeded message back. And ICMP version 6 also sends a time exceeded message. Instead of the IPv4 time to live field, ICMP version 6 uses the IP version 4 hop limit field to determine if the packet has expired. So remember, ICMP version 4 packets and ICMP version 6 packets are slightly different because one is using the IPv4 protocols and the other one is IPv6 protocols, like the systems. So therefore, the hop limit field in IPv6 is used to determine the packet expiration time. And note the time exceed messages are used by Traceroute tool. So in this case, they are sending a ping to 8.8.8.8 and that get reply back with the time to live expired message. ICMP version 6 messages. The ICMP version 6 has new features and improved functionality not found in ICMP version 4, including 4 new protocols as part of the Neighbor Discovery Protocol. Remember, ND, Neighbor Discovery, we quickly go over in our previous module. So that's what this is referring to. Messaging between an IPv6 router and an IPv6 device include dynamic address allocation, and that is done through router solicitation RS messages and router advertisement RA messages. Again, we quickly went over this in our previous module as well, and this is part of the IPv6 infrastructure. Messages between IPv6 devices, including duplicate address detection and address resolution, are done through NS and NA, which are like neighbor solicitation messages and neighbor advertisement messages. ICMP version 6 Neighbor Discovery also includes the redirect message, which has a similar function to the redirect message used by in ICMP version 4. So just remember that. Router advertisement messages or RA messages are sent by IPv6 enabled routers every 200 seconds to provide addressing information to IPv6 enabled host, which we have already covered in our previous module. These RA messages can include addressing information for the host such as prefix, prefix length, DNS address, and domain name. A host using a stateless address auto configuration known as SLAC will set its default gateway to the link local address of the router that sent the RA. So remember that a host using a stateless address, a SLAC, will set its default gateway to the link local address of the router that sent that router advertisement message. So this is what that's showing on the right hand side of this diagram. An IPv6 enabled router will also send out an RA message in response to an RS router solicitation message. In this particular figure, the PC1 sends a RS message. So this PC1 is sending an RS message to determine how to receive its IPv6 address information dynamically. So basically, this router solicitation message was sent by the PC1 with the IPv6 configuration set up. R1, which is the router 1, replies to the RS with an RA message. Router advertisement message will be sent out from this router 1, R1, as a response to the router solicitation message that it received from that PC1. PC1 sends an RS message that similar to something like, hi, I just booted up. Is there an IPv6 router on the network? I need to know how to get my IPv6 address information dynamically. So if PC1 was a human, that would be pretty much the type of communication happening here. So they're saying, hey, I just boot up, I need an IPv6 address, and is there any IPv6 router available so that I can get that information dynamically? Then when the R1, the router 1, receive that message, the information that being sent out from R1 is a RA message. So that RS message is saying, hi, I need the IPv6 information, and the RA message, which is sent out by the router to the PC, gonna say, hi, I'm IPv6 enabled device. Hi all IPv6 enabled devices. I am the router 1, and you can use the Slack to create the IPv6 global unicast address, and it will give out the prefix that can be used. And then you'll tell, by the way, use the link local address of such and such for the default gateway. Because remember, the default gateway here for this R1 is this one, FE80::1, and it's going to send out that as the default gateway information. A device assign a global IPv6 unicast or link local unicast address may perform duplicate address detection, or DAD, to ensure that the IPv6 address is unique. So then once that information has been reached to the PC1, it's gonna use the duplicate address detection, or DAD, to ensure that the IPv6 address that it has right now is unique to that network. To check the uniqueness of an address, the device will send an NS message with its own IPv6 address as the targeted IPv6 address. If another device on the network has this address, it will respond with an NA message notifying to the sending device that the address is in use. But please keep in mind, the DAD is not required, but RFC 4861 recommends that the DAD is performed on unicast addresses. If you have a Windows computer, most of the Windows computers already have DAD enabled, because since Windows Vista, every Windows operating system use DAD in their configurations of IPv6 addresses. To determine the MAC address for the destination, the device will send an NS message to the solicited node address. The message will include the known IPv6 address, which is the targeted one. Then the device that has the targeted IPv6 address will respond with an NA message containing its Ethernet MAC address. So in the figure on the right hand side here, R1 sends a NS message with the 200:DB:8:ACAD:, so on and so forth, asking for its MAC address. And as a result, those NA messages going to respond back containing that MAC address information, so that that information can be used by the device. Ping and traceroute test. Ping, test connectivity. Most of you are probably familiar with the ping command, because we often use the ping command to test connectivity between devices within your own network, as well as pinging outside connections such as Google to test if we have a proper connection to the internet, for example. So the ping command is an IPv4 and IPv6 testing utility that uses ICMP echo request and echo reply messages to test connectivity between hosts. And it provides a summary that includes the success rate and average roundup time to the destination. So that's an important concept that may show up on your quizzes. So what does the ping command do? The ping command use ICMP echo request and echo reply messages to test connectivity. And those messages are then used to provide a summary that includes the success rate and average round trip time to the destination. If a reply is not received within the timeout, ping provide a message indicating that a response was not received. It is common for the first ping to time out if address resolution needs to be performed before sending the ICMP echo request. So what that means is when you first start sending the ping, it is very common to see sometimes first 1 or 2 ping to time out as the ARP or ND needs to be performed within the network before sending the ICMP echo request. So especially on your labs, when you try to test your devices either on EVE-NG, like some kind of simulation program, like an emulation program, or Packet Tracer, which is a simulation program, it try to mimic, like Packet Tracer, for example, a real world scenario. So when you first put all your devices on a network and you start pinging your end devices, the first couple of pings or first ping may drop, like it will go timeout because the network may be still performing the ARP or ND. On the right hand side of the screen, you can see that they show a ping that sent to 192.168.20.2, and then it come back saying sending that message, and there is a timeout of 2 seconds, and we have a success rate of 80%, which is 4 out of 5 ping has been sent out, and it shows the roundup time. And the first ping may have been lost in this case because of the ARP and ND. And this screenshot is from a Cisco device, a Cisco switch or a router. That's what is showing here. And in here, there is another ping sent using a IPv6 address, and again it's going to send 5 pings here, and the ICMP going to come back with, in this case, 100% success rate because the ND probably have already done its work on the network. Ping the loopback. Ping can be used to test the internal configuration of IPv4 or IPv6 on the local host. To do this, we can ping the local loopback address. So if you are using IPv4, if you would like to ping your loopback address to test your IPv4 internal configuration, we're going to use 127.0.0.1. Remember that special IP address for loopback for IPv4? So that's the one we're going to ping. For IPv6, it's going to be ::1 because that's the special reserve IP address for IPv6 loopback. A response from a 127.0.0.1 for IPv4 or ::1 for IPv6 indicates that IP is properly installed on the host. So what the loopback address is doing, it is testing if the IPv4 and IPv6 is properly configured within your device. An error message, however, indicates that the TCP IP stack is not operational on the host. So that means it's basically pinging itself to see if the TCP IP is properly configured on that device. And if it is not properly configured, that the loopback ping will fail. This is true for both IPv6 and IPv4. Ping the default gateway. Another way that we use the ping command is to test the ability of a host to communicate on the local network. The default gateway address is most often used because the router is always normally operational. So routers are typically always turned on in a networking environment. A successful ping to the default gateway indicates that the host and the router interface serving as the default gateway are both operational on the local network. If the default gateway address does not respond, a ping can be sent to the IP address of another host on the local network that is known to be operational. So what does that actually mean is that we're gonna, as a network administrator who is troubleshooting your network, the first thing we're gonna do, we can ping the interface of the default gateway, and it should respond back if everything is working correctly and perfectly. However, if the default gateway address does not respond, you can use another IP address that within the network to see that if the ping from that device gonna be responding back to you. That may indicate some kind of a issue with the reachability of your default gateway. Ping a remote host. Ping can also be used to test the ability of a local host to communicate across an inter-network. A local host can ping a host on a remote network. A successful ping across the inter-network confirms communication on the local network. Please note, many network administrators limit or prohibit the entry of ICMP messages. Therefore, the lack of a ping response could be due to the security restrictions. So as I mentioned before on previous slides, that you may have a firewall on a server that is preventing ping messages from being sent out or received. So if you try to ping a remote server that has the ping packet block, that packet may not come back as a ping response. So just because of your ping is unsuccessful doesn't mean that you have a network connectivity problem, because you may be pinging a server or a device or an interface that has a security protocols applied so that they won't take the pings. An example of this actually would be if you try to ping the SATE website, Southern Alberta Institute of Technology SATE website. I believe their servers currently block all ping messages, and you would not be able to ping that server, and you will get a unsuccessful ping across that network. So when you are pinging a network, you need to also look it up and see if that network or device or that particular interface can take those pings. So there are no security policies applied to that. Traceroute. The traceroute is basically test the path. Traceroute or Traceroute is a utility that is used to test the path between two hosts and provide a list of hops that were successfully reached along that path. So what that basically means is, in this case, there we are doing traceroute 192.168.40.2. And what happened is that message being sent out across multiple hops, and each hop that it goes through get listed with the traceroute command. So traceroute provides round trip time for each hop along the path and indicates if a hop fails to respond. An asterisk, which is like a star like that, is used to indicate a lost or unreplied packet. This information can be used to locate a problematic router in the path, or may indicate that the router is configured not to reply. So if you have multiple routers within a network, you can use the traceroute command to figure out a router failure or a router that is configured with firewall settings, security settings, so that it will not respond to that traceroute command. So that's what you can do with the traceroute. So if you send a ping command from your end device to the next end device, if it fails between your device and one of those hops that we have with the end device, it will not tell you exactly where the failure happened. But with traceroute, you sometimes, in most cases, would be able to pinpoint which router between you and that device that you are sending this request where the failure happens. So you can may be able to pinpoint which router that the command fails. Note the traceroute make use of the function of the time to live field in IPv4 and the hop limit field in IPv6 layer. IPv6 in the layer 3 headers along with the ICMP time exceeded message. This is an important concept and will show up on your Cisco NetAcad exams, both CCNA and CCNP exams. There may be some multiple choice or written questions. They will ask you, what does the traceroute use? So the traceroute use the time to live TTL in IPv4 and the hop limit field in IPv6 layer 3 headers. So that's what they are using to using for the traceroute command. The first message sent from traceroute will have a time to live field or TTL field value of 1. This causes the TTL to time out at the first router. This router then responds with a ICMP version 4 time exceeded message. Traceroute then progressively increments the time to live field from 1 to 2 to 3 to 4 and so on for each sequence of messages. So the very first message that traceroute send will have a time to live field value of 1, but the next message will have 2, 3, 4 as it increments through the TTL field. This provides the traceroute with the address of each hop as the packets time out further down the path. Time to live field continues to be increased until the destination is reached or it is incremented to a predefined maximum. So what happened in here is that the TTL field on the very first traceroute will have a field value of 1. The very first message will have 1. But that will result in the first router to respond back with ICMP v4 time to live exceed message. And as a result, the traceroute then start increasing that time to live field to 2, 3, 4, 5, so on and so forth, one increment at a time. And it will keep doing that until it reaches the destination or we have a predefined maximum. So that's how the traceroute operations works. There is a packet tracer activity available to you in your Cisco NetAcad. If you have access to those, please go ahead and download the packet tracer lab activity called Verify IPv4 and IPv6 addressing. And that will give you a complete, comprehensive hands-on training on what we have just covered. If you do not have access to this packet tracer file, I will try to obtain a copy of that packet tracer file and upload to my sanuja.com website. And if I do that, I will leave a link in the description of this video so you can go ahead and download it and do them. There is also another packet tracer file on your Cisco NetAcad called Use Ping and Traceroute to Test Network Connectivity. If you have access to NetAcad, you can go ahead and download it and do them. If you do not, I will try to get hold of a copy of this packet tracer file and post to my website so you can download it and do them. And that particular packet tracer file will help you understand how you can test IPv4 and IPv6 connectivity. And that would bring us to the end of this lecture, and I will go over what we learned in this module. Again, there is a packet tracer file called the Use ICMP to Test and Connect Network Connectivity. You can go ahead and download it from Cisco NetAcad, or you can download it from my website once I figure out how to obtain that file and post it to my website. There is also a lab activity you can do called the Use Ping and Traceroute to Test Network Connectivity. If I get a copy of that, again, I will post it. If not, you should go ahead and download from your Cisco NetAcad and do that for your, for understanding of this particular module concepts. And now I will go over everything we learn in this module as a summary. In this module, we learn the purpose of the ICMP messages is to provide feedback about issues related to the processing of IP packets under certain conditions. And we learn the ICMP messages common to both ICMP version 4 and version 6 includes the host reachability, destination or service unreachability, and time exceeded. We also learn the messages between IPv6 router and IPv6 device include dynamic address allocation that has the RS and RA messages. And the messages between IPv6 devices includes the redirect, which is similar to IPv4. And those redirect messages are the NS and NA messages. We learn about ping, which is used by the IPv4 and IPv6. And those ping messages, those ping commands use the ICMP echo request and echo reply messages to test the connectivity between hosts. Ping can be used to test the internal configuration of IPv4 or IPv6 local host, which are basically the loopback addresses. If you use the ping with loopback address, you can use a test the internal configurations or TCP IP stack of your device. That's what the internal configuration is testing. Then we learn the traceroute, which generates a list of hops that were successfully reached along a path. So if you can use a traceroute from your device to a end device in another device or to a router port to see if there is a failure between you and the device that you're trying to reach. And if you like this video and if you like these type of lectures, please don't forget to thumbs up this video and subscribe to my channel. In the next few weeks, I will post the new modules associated with the Cisco NetAcad Introduction to Networks lecture series. Until next time, have a nice day and good luck with your exams.